Okay, we're on page 7 of the notes here for section 5.4, and we were getting some practice with perfect square trinomials. So the first thing you always want to look for is the greatest common factor, and these all divide by 3. So I'm going to pull that 3 out. 4x squared plus 4x plus 1. And at this point, you should notice, if you're trying to look for these problems, that you got a perfect square on each end. And square root of the front one is 2x times 2x, so it'd be 2x. And the square root of the back one is just 1 times 1. So 2x times 1 is 2x, and you double it to get this one in the middle. So this works out. All you do here is take the square roots of the ends. 2x times 2x gives that 4x squared. And 1 times 1 to get the 1 on the other end. And you borrow the sign of the middle both times. And since you have a repeat factor, you can use an exponent to express it. Second power. Okay, we're going to do the same thing on this one here. The greatest common factor on this one is negative 6x. So I'm going to pull the negative 6x out. We get 4x squared plus 30. Sorry, that's 20x. And then plus 25. You can take your calculator and divide all of those numbers by negative 6 to see where I got these. Now, at this point, you should immediately notice that we've got a perfect square there, 2x times 2x, and a perfect square there, that would be 5 times 5. And then you multiply those, 2x times 5 is 10x, double it to get the middle. So we're good. And all you're going to do here is use those square roots again. And a lot of times I just mass produce this because you're going to use the same factor down here in the squared version. So 2x times 2x, 4x squared. 5 times 5 to get to 25. And you always use the sign that's on the middle term. So a plus sign and a plus sign. And put your plus sign. Okay, the last type of factoring that we're covering here is a difference of perfect squares. Difference means subtraction. So you're generally looking for a subtraction in the middle of two perfect squares. So let me give you an example here. This one here is a subtraction in the middle of two perfect squares. The front one is 5x times 5x, and the back one is 7 times 7. Okay, you need to know the title. These are called difference of squares problems. Now, these are not trinomials. You'll notice there's just 2 parts instead of 3 parts. So that's kind of a dead giveaway also. Okay, what these do, you just take the square roots of the ends, and you always use a plus and minus sign. So you can set up the plus and minus sign before you start. And it's going to be 5x and 5x and 7 and 7. Those are the square roots of those terms. For instance, 7 times negative 7 is negative 49. Now, you can't use the squared version on this. You can't use that exponent version because these are different. That one has a plus and this one has a minus, so it's not the same value. You just have to leave it like this. Now, you might look for common factors before you go on. Okay, so this one might have a common factor, but I don't see one. The variables are actually different here. And I don't think there's a number that goes into 36 and 25. So we're just going to go ahead and set this up. These are perfect squares, and there's a minus sign between them. This binomial here is a difference of squares problem. We're going to go 6m squared times 6m squared, and the back half is going to be 5n times 5n. And let me explain why there's no middle term. I'm going to go back to the last problem to do that. Normally, the middle term comes from the inside and the outside combined, but you can see that in the problem I just indicated there, it's 35x minus 35x. So here, for instance, you get 30m squared n and a minus 30m squared n. So the middle term always cancels off on these, which is why they're two-part binomials instead of trinomials like the other ones were. Okay, look for common factors first. So what we have here is a common factor on this next problem of 6. And then we have a minus sign with perfect squares around it. So that's a difference of squares problems when you see a minus sign between two perfect squares. The first one's a perfect square because it's x times x, and the back one is 3 times 3, and that problem's done. These are very easy problems. Now, I'll remind you that if you see a negative in the front, you should always take out the opposite of the GCF. So here, the GCF would be 2, but we want to take out a negative 2, and there's also an x involved. And now you should be able to see how this is going to break up. We have a difference of one square and another square, difference of squares. So it's x times x and 3 times 3 with a plus and minus sign. And guys, that's it. We're done with section 5.4. And I hope these last ones here, these difference of squares, are the easiest for you. They usually are. All right, thank you very much.